Hi guys, this is section 7.3 and this is on negative integer exponents. Here's a journal choice for you. It's pretty easy to do whenever you have a calculator, so this might be something that interests you and I encourage you to take a look at it. Okay, I'm going to move this so that we can see a little better. Okay, what do we know about exponents? We discovered all the exponent rules in the last section here. So basically what we're going to do here is talk about negative exponents in the same way. Remember when you have x to the 8th over x to the 4th. The rule said to subtract the exponents. If that was the case, we would get x to the 4th because 8 minus 4 is 4. And that happened, if you recall, from all those pairs of 1, the 7. So x over x that equals 1, x over x that equals 1, x over x equals 1, 1, 1. Okay, so then I have x to the 4th. This makes perfect sense to everyone. What would happen if we had x to the 4th over 8th? Well, the rule says 4 minus 8. That should give us negative 4. But what do we really get? Well, let's think about this. If I have the 4x being multiplied on top and the 8 on the bottom, this process will still be the same. And 1, 1, 1, 1. Now, there's not a 0 up here. There's still a 1 up here. So now I have 1 over x to the 4th. So I get 1 over x to the 4th when I do the canceling method. When I do the rule method, I get x to the negative 4th. Well, what does that tell us? Well, that tells us what a negative exponent is. This is the negative exponent theorem, and it says for any non-zero base b, so anything can be b. It can be a number, a variable, anything. If you have a real exponent n, b to the negative n is 1 over b to the n. I think of this as a set of rules. Anytime I see a negative exponent, I want to make it positive, and it does that by jumping the line. There's a smiling magic trick. It's not really magic at all, actually, but like if somebody says a joke and then you're laughing and then you wipe your hand over your face and then you're frowning, it always reminds you of that. Because every time you jump the line, the sign changes. You can go from negative to positive, up and down when it jumps the fraction sign. And we'll do a lot of examples and this should make sense to you. The most important thing, this negative exponent has nothing to do with the negativity of the sign or of the number. I don't know if that's what I want to say. It has nothing to do with the number, the base being positive or negative. It has actually nothing to do with the base. It only has anything to do with the exponent. It just tells you that it's going to be on the bottom of the fraction bar. It has nothing to do with the value of the base. Okay. So all exponent rules apply. So basically everything we did in the section previous will hold true here, except you're just going to have negative numbers involved. Okay. Here is the proof. This is the theorem we already wrote down, and this is going to make sense to you. I'm going to walk you through this. We're going to prove by assumption. We're going to suppose that b to the negative n equals x. We're just going to say, let's say it equals x. Well, it is legal for me to multiply both sides by the same thing because of multiplication property of equality. So I'm going to multiply both sides by b to the n. Okay? Well, I can use the product of powers postulate that tells me to add those exponents and I get b to the 0. Still have b to the n times x right here. Well, we know that b to the 0 is 1. So now I have 1 equals b to the n times x. I want to get x by itself. Divide both sides by b to the n. X is 1 to b over n. But I already know that x is b to the negative n. So now I'm going to use substitution. And I'm going to substitute this into here. And I get b to the negative n equals 1 over b to the n. This is the proof. It should make sense to you. I don't expect you to do that by yourselves. But when you follow it, you should be like, yeah, makes sense. Okay. So you have seen negative exponents before in science class. Scientific notation. I think you probably saw them first time in 7th grade because I did teach it when I taught 7th grade for a couple of years. The rule on scientific notation, the first number has to be a number between 1 and less than 10. Okay? has to have a 9 in front of it. 1 and something with a 9 in front of it. It can have lots and lots of decimals, but it has to be a number between 1 and less than 10. Then we always say times 10 to the, and this number, if the whole thing is going to be big, it'll be a positive number, and if the whole thing is going to be small, it's a negative number. And it moves it left and right. If it was a big number, I want the decimal moved to the right because that will make it a bigger number. If it's a little number, I want to move it to less because that makes it a number closer to 0. This is really good in science because a lot of times they're dealing with really large quantities and really small quantities that get really close to 0. And when it's a base 10, that tells us to move the decimal. Okay, so you've done this before. And we are going to look at, and I don't even have a calculator handy, but I do now. So we are going to write these without an exponent. So we're going to kind of take these from exponents to fractions because all these negative exponents are going to turn these into fractions. So I have a negative exponent here. I cannot have negative exponents in my answer. So I'm going to change this to 1 over 4 to the third. So it was on top, I move it down below, and then it becomes a positive exponent, which is what I'm looking for. 4 to the third power is 64, so I have 1 over 64. Okay, this one is a little different because I have 5/6. The whole thing is to the negative first power. I want a positive exponent. So I would put 1 over 5 to the 6, but no one's going to write that. If you remember, that is 1 divided by 5/6. When you divide fractions, that's the same thing as multiplying by the reciprocal, so it's 1 times 6 to the 5th. So we have 6 over 5, 6/5. When you have a negative exponent applied to a fraction, you will take the reciprocal of that fraction. If it was something other than 1, both quantities would be taken to that power. Another way you can think of that is you could have kind of pow-tributed here, and you could have had 5 to the negative 1 over 6 to the negative 1, and then I want to make this positive and this positive, so they will switch places, 6 to the 1 over 5 to the 1. There's lots of ways to walk yourself through these problems. Okay, this one, there's 2 ways to do this. The easiest way is when I notice this negative exponent, I want to make it positive, so I then have 1 over, still negative 5, but it's now not to the negative 2 because I put it down below. It's going to be squared. Negative 5 squared is 25, so that's 1 over 25. The other way you could have thought about that is you could have said negative 1 times negative 5. Oh, just kidding. Pretend I didn't do that. Negative 1 times 5. Still, I have a writing problem today. To the negative 2. Then you could have pow-tributed negative 1 to the negative 2, 5 to the negative 2. You could have done it that way if you wanted to get rid of those fractions, but I would never have done it that way. But make sure you don't lose your parentheses. I said fractions. Don't lose your parentheses. Okay, here, look, same base. This is good news. Same base. I can add the exponents. That's 3 to the negative 3, which is 1 over 3 to the third, which is 1 over 27. Or you could have taken 1 over 3 squared times 1 over 3 and then multiplied that way, which is 1 over 27. Doesn't matter. You can change them first, or you can apply your exponent rules. Here, negative 10 plus 10 is 4 to the 0, which is just 1. Or you could have taken 1 over 4 to the 10th times 4 to the 10th. 4 to the 10th, 4 to the 10th kind of cancels out, leaving us with 1. Okay, in this case, the negative is going to remain because this exponent does not apply to that negative. I am going to have negative 1 to the negative third power. No, just kidding. I'm off my game, guys. Okay, I got the negative here. I have 1 to the negative third power over 5 to the negative third power. I don't want those negative exponents, so it gives me negative 5 to the third over 1 to the third, which is negative 5 to the third, which is negative 125. That's one way. You could have just inverted this and then made it positive. Negative, if I invert this as 5 to the third, negative 125. Be careful with these. Since there's no parentheses here, just the 5 is getting taken to the third power and the negative remains in front. Here I have same base and a division sign. I can subtract the exponents. Negative 1 minus 3 is 5 to the negative 4th, or 1 over 5 to the 4th. Is that 625? Yep. 1 over 625. Another way of thinking of it. This positive is okay, so it can stay there, but this one needs to go down below. So that leaves you with 1 over 5 to the first times 5 to the third. Then you could have added the exponents. 1 over 5 to the fourth. Still, 1 over 625 is what you'll get. This is a complete fraction sign. 12 to the first power over 12 to the third power. 1 minus 3, 12 to the negative 2. That's 1 over 12 squared, which is 1 over 144. 6 to the negative 2, 1 over 6 squared. This one's pretty easy. 1 over 36. Negative 3 to the negative 4th becomes 1 over negative 3 to the negative 4th. Remember, positive 4th now. Once I jump that fraction bar, becomes positive. Negative 3 to the 4th is going to be positive. It's the same thing as 3 to the 4th, really, which is 81. Okay, if you have any questions on any of these, jot them down, ask me, and we can go over those together in class. Okay, scientific notation, fun times. Okay, the number first has to be between 1 and less than 10. So what can I find here? Oh, how about 3.4? I'm going to change that to 3.4 because that meets my criteria of being between 1 and less than 10. 3.4. Now, this is a little number, so it's going to be times 10 to the negative. How many spots did I move from here to here? 1, 2, 3, 4 times 10 to the negative 4th. Okay, on this one, I'm going to rearrange this a little bit. So it's going to be 8 times 22 times 10 to the negative 2 plus negative 4 is negative 6. Well, 8 times 22 is 176 times 10 to the negative 6. That does not meet my criteria. Okay, what does this even equal? Well, it's 176 times 10 to the negative 6. I would move that 6 to the left. 1, 2, 3, 4, 5, 6. That's what that equals. How can I make it meet the criteria? Well, I want it to be 1.76 times 10 to the, how many spots do I need to move it? 1, 2, 3, 4 spots. This is a little number, it's a negative 4. Okay, 4.2 over 2.1. I'm going to do this as two separate problems. 4.2 divided by 2.1, we should figure that out. It is 2 times 10 to the negative 3 minus 2, negative 5. That does meet my criteria because this number is between 1 and less than 10. 0.3 divided by 3 is 0.1 times 10 to the negative 1 minus negative 4. Be careful with that, is 3. That does not meet my criteria. This number is too small. 0.1 times 10 to the third, I'm going to move it 3 spots. 1, 2, 3, it's 100. How can I write 100? Well, it's going to be 1 times 10 squared. Okay, 0.094 times 275, 25.85 times 10 to the negative 1 plus 5 is 4. Move it 4 to the right, 2, 5, 8, 5, that's 2, 3, 4. It's a big number. I need to change it to 2.58. That gives me my criteria of between 1 and less than 10. Times 10 to that's a positive because it's a big number. It's here. 1, 2, 3, 4, 5 spots. Okay, they want us to write this in scientific notation. Okay, I need to make this number between 1 less than 10, so the decimal will be right here. 2.2957. It's a little number, so I'm going to have a negative exponent. How many spots do we move it? 1, 2, 3, 4, 5. and that is acres. Okay? Where do I need my decimal? Right here. 1.5625. It's a little number again, times 10 to the negative 123. Okay, so how can I change this? 1 square foot, I want to change it to miles squared. Well, let's change it to acres first. And I get, actually, let's do this the old way that we do in chemistry. 1 square foot. We're going to multiply it by some conversions here. I can change square feet to acres. And 1 square foot is the same thing as 2.2, oh my gosh, that is horrid. 2.2957 times 10 to the negative 5th acres. I can do this because I'm multiplying by 1. Since those two things are equal, I just multiplied it by 1. And the square feet cancel because that equals 1. Now I want to get rid of acres because I want to change that to miles squared. So I'm going to put acres down here. I'm going to change miles square miles up here. 1 acre is the same thing as 1.5625 times 10 to the negative 3rd square miles. So I'm going to multiply these two together, and I get 2.2957 times 1.5625. Ooh, I'm so happy it fits right into my 3.58703125 times 10 to the what? Well, negative 3 plus negative 5, negative 8. Itty bitty. That's a pretty tiny number. This is fun. Okay, here are rules with variables, not just numbers. I think these are easier personally, so let's go over a couple of these. And I'm sure that some of these odds will cause you some problems, so make sure you jot them down and I will go through them with you. Okay, same base, so add these. X to the negative 1. The directions say positive exponents only are allowed, so I'm going to change that to 1 over x. Okay, the next one, this is power of a product, and we got some power of a power in here. I have 4 to the 5th times m to the negative 15th. 4 to the 5th is 1024 m to the negative 15th. I'm not allowed to have m to the negative 15th. That needs to move below. So I have 1024 over m to the positive 15th. Okay, here I'm going to add these exponents. Negative 7 plus 4 is m to the negative 3rd. It's 1 over m to the 3rd. Here I will subtract. Negative 5 minus 1 is e to the negative 6. 1 over e to the 6. Here let's take 7 to the negative 2 times 7 to the 6th. That's 7 to the 4th, and I add those exponents. G to the negative 4th. 7 to the 4th is okay, but I'm going to change it to a number, 2401. G to the negative 4th is not okay. I need to move that below to make that a positive exponent. Okay, 38 is a doozy. Everybody in here is going to be taken to the negative 2 power. So I have 3 to the negative 2, f to the negative 2, over 4 to the negative 2, h to the negative 2. Or you could have inverted this first and made that positive. Let's do this piece first. I'm going to get 4 squared over 3 squared. I'm going to put h squared over f squared. So I have 16 over 9 h squared over f squared. Okay, now this one I now have times, everybody's okay here, 4f squared over 3h. Remember when you multiply these, you can look for pairs of 1. The f squareds will simplify out. The h squared and the h simplified out, leaving me with the h on top. 16... I get 64 over 27. And that does not simplify. So I get 64 over 27, but don't forget I'm still left with this h here, 64h over 27. If I make a mistake on that, someone let me know tomorrow. Okay, I'm going to erase some of this because it is a little mumble-jumbled. Okay, 5 to the negative 2, and this will, oh, look, everybody needs to be taken to the second power. So I have 5 to the negative 4th, y to the 4th, everybody to the negative 3rd power, 2 to the negative 3rd, x to the negative 3rd, y to the negative 12th. You can do nothing with this 5 and the 2. They are not the same base. So, pretty much everybody is going to be moving here because all these have negative exponents except this one. You have the option of adding those y's first if you want. Okay, let's go ahead and do that. So 5 to the negative 4th, the y has the same base, so I have y to the negative 8th, 2 to the negative 3rd, x to the negative 3rd. Now everybody's going to move, and I'm left with 1 over, and this is for this answer here, 1 over 5 to the negative 4th becomes 5 to the 4th, which is 625, times 8, times y to the 8th, times x to the 3rd, and I get 1 over, what's 625 times 8? That's so big. 5,000. 1 over 5,000, x to the 3rd, y to 8. It's nicer to have it in alphabetical order. Okay, that one was the hardest one so far. 42, negative 1. That's easy. That just means that you invert the whole fraction and make it positive. So 3 r to the 6 is now on top, and 4 r to the 5th is now down below. 6 minus 5 is 1. 3r over 4. Okay, I would like you to really work through these, and if you have any questions on those, to jot them down because your worksheet tomorrow is going to be kind of small anyway. All right. Write these without fractions. Okay, that's going to be x to the negative 11th because that's 1 minus 12, negative 11th, and this time they're saying negative exponents are okay. This will be 1/2. 4 minus 6 is negative 2, x to the negative 2. Okay, they want without fractions, so a to the negative 3rd is okay, c squared is okay, but I got to move these guys up. That'll become b to the 6th and c to the 3rd. Clean it up a little bit. A to the negative 3rd, b to the 6th, c to the 5th. And last, I have 5n times 5 to the 3rd, n to the 6th. Got a power tribute here. The 4 can actually stay. Oh, they said without fractions. Technically, I guess you could write 0.5 here if you wanted to. So I have 5 to the 4th. 625 over 4 n to the 7th. Okay, 156.25 n to the 7th. Okay, that's it for that, and that's it for the notes. See ya.